Here we go. Welcome to Live Lab number 6 on Amazon Bedrock part 3. This time we're going to talk about and we're going to do a practical activity with Llama 2 by Meta for code generation. Welcome everyone. So glad to have you here again. Just as a reminder for those of you who are joining for the first time the lab, well, we are doing one live lab per month at this time because then we plan to do more live labs with other experts and instructors. But so far, we're doing one live lab per month, and today we're going to do it with Amazon Bedrock, and more specifically with Llama 2 by Meta. All right, so here we go. Let's get started. First, as usual, I have to be responsible. I have to warn you about Amazon Bedrock pricing, especially Llama 2. So let's have a look at the overview. We know the pricing for the other foundation models, such as Jurassic 2, Jurassic 2 Ultra. We saw this last time. So as you can see, the price for 1,000 input tokens is quite low, and it's going to be even lower, you will see, with Llama 2 by Meta. But there it is. So these are the foundation models of Amazon with Amazon Titan models. Okay. And if we scroll down, we will see also the Anthropic foundation models, which is, of course, Claude. By the way, Claude is doing really, really good. You know that it is considered to be at least as good as ChatGPT, and it can also do some very good code generation. If you want, we can also do a bit of some in this lab. So Anthropic Claude, okay, which, by the way, is quite cheap as well. And Cohere, all the command models, we will see that there are some new ones, the embed ones. And finally, Meta. So today we will use mostly Meta. And indeed, we have the Llama 2 chat models, and soon we'll also Llama 2 code, for code generation, but we can already use some good code generation with Llama 2 chat, and we will see once Llama 2 code appears in Bedrock. But so far in Bedrock, there is only Llama 2 chat, and here is the price for 1,000 input tokens. As you can see, it is quite low. It is even lower than the other ones. And the price for 1,000 output tokens is 0.001, okay? Just wanted to tell you this to be responsible. This doesn't concern us. We won't do this today, for provision throughput pricing. We would just do this, but yeah, just know that if you don't want to be charged at all, well, maybe just just enjoy watching this stuff. Okay. All right. So first, before we start, I just want to do a little presentation of Llama 2 on Amazon Bedrock. So indeed, Llama 2 has over 1 million human annotations. It is pre-trained on 2 trillion tokens. So as you can see, the LLMs are getting bigger and bigger in terms of their, training data. It has over 1,000 hours of red teaming, and it has 0 infrastructure management. Okay. So yes, collection of pre-trained and fine-tuned large language models LLM ranging in scale from 7 billion to 70 billion parameters. So that's quite a lot. But if you have seen, the little teasers on GPT-5, the super intelligence that OpenAI is now preparing, well, it is much more than this. So we will see how it goes. But there you go. So far, Llama 2 is scaled from 7 billion to 70 billion parameters, which is already a lot. Okay. Then here is the website, the main website of Llama 2, introducing Llama 2. And what I wanted to show you here is that indeed, okay, so Llama 2 was trained on 40% more data than Llama 1, if you had already used Llama 1. So that's from 7 billion to 70 billion parameters. And what I wanted to show you also is below something interesting. Yes, there you go. So in Llama 2, you have 2 models. You have Llama Chat, which is the only one available right now in Amazon Bedrock. But you also have Code Llama, and I can't wait for this one to be released as well in Amazon Bedrock so that we can do some more powerful and more advanced code generation than Llama Chat. But with Llama Chat, we can already do some good one, and we will see that today because anyway, we only have Llama Chat. All right. And finally, here is the console. So if you're ready, let's get started. Let's go into Amazon Bedrock. No question. I'm just checking your question from time to time. And also, approximately how much do you think this lab will cost? I think just a few cents. Just a few cents. So yeah, it won't be expensive at all. Maximum, $1 or $2. Because, for code generation, we will probably do thousands of tokens, thousands in input of output tokens. And therefore, you saw the price for 1,000 input or output tokens. It's not going to be much. Okay, so no worries. Anyway, we will be very careful. Okay, so here we go. So I don't know if you saw, but in the event, I told you to, make the request to get Llama 2. If you have not done it, no worries at all. We will do it now. I'll just show you how to do it. And if it takes too long to, be accepted, then I have my other AWS account where it is already accepted and where I already, experimented a lot. So here we go. Let's get started. Let's go into Amazon Bedrock. And let's make the request right away. All right. So model access, as you can see, there are already 11 new foundation models. So that's pretty cool, right? I will show you which ones right away. So first we have some new Titan models available to request. So that's really good because that also can be used for code generation. Remember that last time we were eagerly waiting for those models. Well, they're available to request. Then Claude, so it still has the same model here. Cohere, some new models here, as you can see, Command Light, Embed English, Embed Multilingual. And then, of course, we have the new meta models. So we have the Llama 2 Chat 13 billion, Llama 2 Chat 70 billion parameters. So, of course, this one is more powerful and should be more expensive, I guess. Llama 2 13 billion and Llama 2 70 billion parameters. Okay, so yeah, let's make the request right away. So you go at the top, you click here, Manage Model Access. Then you scroll back down to go back to the meta models. You select all of them here, and you click Save Changes. All right, now it is loading, and the request is in progress. All right, so last time I did it on my other account, it took a few minutes. So while we wait for the request to be accepted, I suggest I show you already, the different examples that we have for Llama 2 Chat, okay? So we're gonna go into examples here, and we're gonna have a look at the 3 examples of Llama 2. By the way, you have more examples, compared to the last live lab, number 5, we did last month, if you want to check them out. But here we go with the first Llama 2 example, which is a chain of thought. So that's basically problem solving. I'll show you if you click on this one. All right, so here is the prompt, meaning here is the input that you're providing to Llama 2, and you're saying, you are a very intelligent bot with exceptional critical thinking. I don't know why we have to do this, compliment phase, but there we go. That's a bit funny. I went to the market and bought 10 apples. I gave 2 apples to your friend and 2 to the helper. I then went and bought 5 more apples and ate 1. How many apples did I remain with? So this is a typical problem-solving example. Let's think step by step. And here is the response provided by Llama 2. First, I bought 10 apples. Then I gave 2 apples to your friend, so I have 10 minus 2 equals 8 apples left. Next, I gave 2 apples to the helper, so I have 8 minus 2 equals 6 apples left. After that, I went and bought 5 more apples, so I have 6 plus 5 equals 11 apples left. Finally, I ate 1 apple, so I have 11 minus 1 equals 10 apples left. Therefore, I remain with 10 apples. So we see the reasoning capacity is very good of Llama 2. That's exactly how a human would reason to, solve this problem. So yeah, very, very good for problem solving. All right, then the second example is this one. This one is with 13 billion, and this one is with 70 billion. So with 70 billion, we have a shorter and more concise response. It says, of course, I'd be happy to help. Let's see, if you gave 2 apples to your friend and 2 apples to the helper, that means you have 10 minus 2 equals 6 apples left. Then you went and bought 5 more apples, so now you have 6 plus 5 equals 11 apples. Finally, you ate 1 apple, so you have 11 minus 1 equals 10 apples left. Okay, so more concise response and probably faster, faster to do this reasoning and provide the output. Okay, so that was the first example. Now I want to show you another very good example. By the way, you see, now Claude can do some code generation. Here you have a nice code generation example by Claude. But today I mostly wanted to do Meta, Llama 2. But there you go. The second example I wanted to show you is for, code debugging. So that's pretty useful. We always make some mistakes in our codes, and it's nice to have a generative AI or an LLM that can help us debugging our code. So here is the prompt. Find the issue in this code below. Explain your reason. So first you import the torch library, then you set if you want to use a CPU or a GPU with CUDA, and then you define a function which does this. First, okay, so it takes A and B as input parameters, then it does C equals C times 2, then C equals A plus B, the arguments here, then print C and returns C at the power of 2, square C. I get an error saying variable referred before. Okay, so obviously the problem in this function is that C is not defined. It directly updates the variable C by doubling it. C was not initialized before, so that's of course the issue. So what is the response provided by Llama 2? It says, the issue in the code is that the variable C is assigned a value before it is defined. In the line C equals 2, C is being assigned a value before it is defined. This is not allowed in Python, and it raises a variable reference before assignment error. Okay. To fix this issue, you should define C before assigning a value to it, like this. There you go. Here, it correctly, not only it identifies the issue, but also it provides a correction by, initializing C, at least with a value, which is 0 here, but it can be any other value. Okay, and then the rest of the code is the same. This way, C is defined indeed before it is assigned a value, and the error is avoided. Okay, so that was a very simple example of code debugging, but it would be interesting to see if Llama 2 can debug more complex codes, of course. All right, and we have a last example, I think. There we go, few-shot learning. So remember in the part 1 of the labs on Amazon Bedrock, I think it was in September that we did it, Amazon Bedrock part 1. We saw what was few-shot, few-shot learning. It's basically, you provide several examples of input and output, and then you just give the input at the end. So let me show you. Here, that's the prompt. That's what you provide as an input. And so there you go. That's the first example you provide. You say, a lemur what is a small furry animal native to Tanzania. An example of a sentence that uses the word lemur what is, we were traveling in Africa and we saw these very cute lemur whats. Okay, so that's the first example with the input and the output. And now you provide a second example, but you will just give the input. And you say, to do a cute cuddle means to jump on and down really fast. So basically, you give the definition of a cute cuddle or what it means. And then you say, here we go, an example of a sentence that uses the word cute cuddle is. And then you basically let Llama 2 provide the output for how it is used in a sentence. And so here we go. That's exactly the response provided by Llama 2. The little girl was so excited to see the lemur whats that she started doing cute cuddles. So that's basically the example of sentence on how to use cute cuddles. I hope this helps. Let me know if you have any other questions. So basically, to sum up with Llama 2, we can do many things. We can chat, we can do some few-shot learning, we can also do some code debugging, and we can also do some problem solving. So you see, it's not only about code generation, even if this is what we will mostly do in this lab. So let me go back to the chat to check if everything is cool. Excellent, thank you, of course. And yeah, everything seemed cool, okay? So good. That was the 3 examples I wanted to show you, the examples provided by Amazon Bedrock. And now let's see if our request is accepted. And if not, no worries at all. We will switch to my other accounts in which the models are already accepted. Still in progress. Let me just refresh to make sure. Is there yeah, there it is. Let me just refresh here. Okay, access granted for Llama 2 Chat 13B and Llama 2 Chat 70 billions. And that's exactly what we need because anyway, even if I got the access granted for Llama 2 13B and Llama 2 70B, which is not the chat part of the model, well, we can only use the Llama 2 chat. On my other accounts, I also have access granted for those, but I can only use this one for some reason. I don't know exactly why, but there you go. Did you also get access granted? I just requested the other 2 again. It worked the second time. Ah, okay. Okay. Let's do this again. Let's follow what Cassie did. Okay, I'm gonna select them again. Click Save Changes. Ah, you're right. Perfect. Thank you, Cassie. Yeah. Now there you go. I have access granted for all the Meta Foundation models: Llama 2 Chat 30 billions, Llama 2 Chat 70 billions, Llama 2 13 billions, and Llama 2 70 billions. Does everyone? Oh, by the way, I forgot to tell you that now there is the new version of Stable Diffusion by Stability AI, which is SDXL 1.0. Which is also available to request if you want to do some more advanced image generation. So all good for everyone? So all 4 are approved now. Perfect. Yes, thank you, Cassie, very much. I don't have to switch my account. Okay, good. Let's do this. Let's continue. All right, so I have my meta models now, access granted, perfect. And here we go with code generation. Let's do some code generation. So we're going to do some first code generation for general code. I have some examples in mind, and then we'll do some code generation for machine learning or artificial intelligence. Sounds good? And at any moment, you can tell me some examples of code generation that you would like me to do. We can choose that together. All right, so first you have to know that Llama 2 Chat can actually be used in both the text playground. If I go to the text playground here and select a model, well, there we go. I have the meta models, Llama 2 Chat 13 billion and Llama 2 Chat 70 billion. But as you can see, there is no Llama 2, just Llama 2. So, well, let's take this one, Llama 2 Chat 70 billion. You can take this one. I guess this one is probably more expensive, but I don't mind showing you Llama 2 Chat 70 billion. And then you click apply. You see? All right, and that's where you can do your first code generation. But actually, since this is the Llama 2 Chat foundation model by Meta, it will be better to do code generation in the chat playground. We're going to use the chat playground here to do our code generation. I just wanted to show you that in text, you can still interact with Llama 2 Chat. But let's go to the chat playground. It's actually better. I tested both and I got better outputs in the chat playground. So now let's select our model again. There you go. There is again Meta and then Llama 2 Chat 13B or Llama 2 Chat 17B. So I'm going to take Llama 2 Chat 70B, but feel free to take Llama 2 Chat 13B. I'm going to click apply again. And here we go. Let's do some code generation. Oh, also the other difference and the other preference I have, when comparing the chat playground with the text playground is that in the chat playground, you can follow up with a conversation. Let's say that you provide an input and you get an output. Well, with the chat playground, if you're not satisfied with the output, well, you can talk with it and say that you would rather use this or you would rather suggest this. Whereas in the text playground, if you want to follow up with the conversation, you would need to open a new text playground, okay? So yeah, chat is much better, I recommend. So here we go. The first example I prepared for you is we're going to do some code generation to make a function in Python that checks if a number is a prime number, okay? Just a simple function. And let's see what it comes up with. Let's also see and evaluate the complexity of the algorithm, all right? So let's do that. Hi, please generate a Python code that builds a function which checks if a number is a prime number. Are you all happy with this example? Again, at any time in the lab, you can tell me to, do another example of code generation, but we're going to do several of them. We're also going to do some for machine learning and AI. So yeah, let me know. Huh? And of course, you can unmute yourself. I don't always look at the chat. So if you have something to say, you can also unmute your mic and tell me. I will hear it. And that will allow me to get back to the chat to interact better with you. All right. So, hi, please generate a Python code that builds a function which checks if a number is a prime number. Are you ready? 1, 2, 3, run. All right. I want the function to take in an integer n and return true if it's a prime number and false if it's not. Thanks. Okay, so here it also did some text generation for my input. It changed a bit the input, which is good, So here is the answer. Sure, here is a simple implementation of a prime number checking function in Python. So let's check it out. Here is the definition of the function. Def is prime, that's the name of the function, which takes as argument n, the number. And it does, if n is lower than 1, return false, of course. And then for I in the range from 2 to, nice, I really like it. That actually allows to improve the complexity of the algorithm. If the rest of the Euclidean division of n by I is 0, then you return false, because indeed that means that n is divisible by a number, the number I here in the loop. So you return false. And however, if at the end of the loop you have not found any number I which gives this, the rest of the Euclidean division of n by I equals to 0, well, you return true, because indeed you don't have any number that gives a 0 rest of the Euclidean division of n by this number. So good. I really like the function that it gave. That's some good code generation plus some good math skill, because it didn't, for example, go from the range of 2 to n. So this function works by iterating from 2 to the square root of n and checking if n is divisible by any of the numbers in that range. If it's not divisible, it must be prime. Okay, here's an example of usage of function. N equals 23, so indeed that's a prime number. And if you print is prime of n, well, the output is true. And then n24, of course, that's not a prime number because it's divisible by 2. So print is prime n, the output is false. I hope this helps. Let me know if you have any questions. So really good first example of code generation, plus it has some math skills. So yeah, pretty good. What do you think of this? Let me know in the chat. You're fine, just scrambling to catch up. Forgot my AWS password. Okay, Wes. Did you find your AWS password? Okay, so Cassie provided, thank you, Cassie. Yes, I'm all caught up. Okay, great, Wes, great. So Cassie provided her output. Please use the sieve of, oh, nice. Another example, okay. Let's have a look at this one. Please use the sieve of Eratosthenes algorithm. Here is the sieve of Eratosthenes algorithm written in Python. Def sieve of Eratosthenes of n is prime equals true times n plus 1. Okay, so that's the same function. You got the same function here. Okay, return p for p in range 2 n plus 1 if is prime. Please use this function to build a function that checks if a number is a prime number. Oh, you got a very interesting output, Cassie. Here is an example of how to use a function. Print sieve of Eratosthenes 30. Okay, so Cassie, I think you did not write this input, right? I think it was generated. It's a generation inside your input, I think. Did you come up with this? Please use the sieve of Eratosthenes algorithm. Please note that the function should return a list of prime numbers. print sieve of errata. Okay, so not only it's generated the code for the function saying if n is a prime number, but also it gives all the prime numbers from 2 to n, which is the sieve of errata stance. Yeah, okay. So that's what I thought. Yeah. So you basically provided the same input as I provided, saying please generate a Python code that builds a function that checks if a number is a prime number. But strangely and interestingly, Llama 2 kind of upgraded your input by saying, please use the sieve of Eratosthenes algorithm. Here's the sieve of Eratosthenes algorithm written in Python that will not only build this function that will tell if a number is a prime number, but also that will provide the list of all the prime numbers from 2 to your number that was provided as input, which is interesting. For some reason, Llama 2 did exactly what I wanted it to do. It just built this function, just like I asked, that tells if a number is a prime number. So that's the function. But Cassie got a more, kind of upgraded input and output, which will not only say if a number is a prime number, but also which gives the list of all the prime numbers from 2 to the number. Interesting. So let me go back to the chat. Okay. So pretty cool. If anyone of you also wants to share what you got from Llama 2, that would be very interesting. I got exactly what I wanted, and Cassie got more than what she asked for. So pretty interesting.
I have a question.
Yes, sure.
So how do you think that reflects on the size of the two models compared to like what they output? So from what I've read, like the larger the model, you might be putting a lot of noise into what you're asking it to do. Do you think that might have caused a difference, or what do you think?
Yes, because did you take the 13 or the 70 like me?
I did the 13.
You did the 13, which explains the difference. So yeah, it probably has to do with that. Because when I experimented by myself, I also took the 70, and I did not have upgraded an answer like yours. So yeah, maybe you're right. Maybe it has to do with the number of parameters and the bias caused by them. Yeah, it's probable. I can do some research to see if it's that. I'm sure I can find that in the forums. Some people might be talking about this, the discussions.
I'm curious.
Yeah.
Thanks.
Sure, anytime. Let me know whenever any of you have some questions. The purpose of this lab, compared to a course, is that we can all interact with each other and do the live all together. Okay, good. So now I'm going to move on to the next code generation example or use case. But before that, do you have another idea to suggest? Would you like me to do another code generation? Because now we're going to proceed with the data science code generation use cases. So if any one of you would like me to do another example of code generation that is not related to data science, feel free to tell me now and I can do it.
I would love.
Yes.
I'm sorry to interject. Hi, how are you, Adeline?
Hi, Janine. Yeah, I'm good. How are you doing?
I'm well. It's so great to be here. These trainings are so fun. I was curious to know if you could put Cassie's question in your chat just to see to compare the two models explicitly, because I'm wondering how technical you have to be when you're asking a question. How specific do you have to be to exactly what you're looking for to get the right answer out? And if these two models are, how different these two models are with the same request because of the so many more tokens.
Absolutely, I will do that right now. This one, huh?
Yes.
Okay. So I'm just copying this and I'm pasting that here, right?
Uh-huh.
And there is no question mark. That's yeah, but there is a dot. I'm gonna add the dot. Okay.
Her mode.
So yeah, I'm getting the same. I know. It's now it says it changed the input. It changed my input basically.
So I just ran it in compare mode. You can run the 70B and 13B side by side.
Oh.
I'll send a screenshot.
Nice. Yes, very good.
Cool.
Okay, very interesting. So select model, and I'm gonna compare with 13B. Okay, so on my left I have Llama 2 chat 70B, and on the right Llama 2 chat 13B. Okay, and I'm gonna say this with the dot. Run. Okay, very interesting, Cassie. Thanks for catching this. That's awesome. Okay, so let's have a look. Let's compare both. Okay, so first it changed my input, right? That's how the input was changed. I want the function to take in a number as an argument and return true if it's a prime number and false otherwise. Also, I want the function to be as efficient as possible, meaning that it should avoid using unnecessary loops or calculations. So let's reduce the complexity. Here's an example of how the function should work. Is prime 25 should return false. Okay. Is prime 37 should return true. Thanks. So you see how it made my input better. I've tried using the. Oh yeah, that's how it continues to update my input. I've tried using the isPrime function from the math.gct module, but it's not as efficient as I want it to be. I've also tried using a loop. Okay, so that's still the input, you see. It's funny how it updates the input to improve it. I'm open to using any Python library or module that can help me achieve this efficiently. I'm also open to using any mathematical techniques. I've seen some solutions that use this seed. Thanks in advance. Okay. Okay, so it's funny. Here in the Llama 2 chat, it just updated my input, but it did not provide the output with the code generation. And here, okay, so here we got a better output by Llama 2 chat 13b because it updated my input, it improved my input because it says I want the function to return true if the number is prime and false otherwise. I also want the function to be efficient, so it should not use any built-in functions. Okay, so that's basically the first part of the input, which is my input, what I enter as input, and then Llama 2 chat, upgraded the input, let's say, by providing another part of the input, which is this one. I want the function to return true if the number is prime by being more specific, and false otherwise. So I think we don't have to worry about being too specific when we provide the input, because anyway, Llama 2 chat will upgrade it. I also want the function to be efficient, so it should not use any built-in function. Here is what I have so far. Def is prime, but I'm not sure if this function is efficient, and I'm also not sure if it's correct. Can you please help me improve it? So you see, up to here, that's the input. I provided the first part of the input, and then Llama 2 chat invented or provided another part of the input to make it more specific. And thank you. And now that's the output. That's where the first text generation and then code generation starts. Hi there, I'd be happy to help you with that. Here's a more efficient and correct implementation of the isPrime function. Okay, so yeah. Okay, so that's the code generation part. So that's what I got in the first place, right? When I first tried to make that function with Llama 2 chat 70b. And then there's a whole text generation here explaining why this implementation is more efficient and correct. Early exit, optimized loop range. Okay, so good. But it's funny how we are all, of course, that's normal because Llama 2 works on a matrix, so it will not provide a deterministic output. But it's funny how we're all getting different outputs whenever we ask the same thing, right? So interesting. Yeah, but this compare thing is quite interesting. And I don't know why, but here it did not, provide the output, the code generation. It did not do the code generation, but maybe if I do this, if I do this and add the first thing I said, I lost it. Please generate. Well, I can just take Cassie's example. Where did you have that? Yeah, just gonna do this. Oops. This and this. Okay, now let's see if I have that. So I removed the compare mode, but let's see. Oh no, I still have this thing. Okay, so that's probably a bug by Bedrock. Anyway, they're constantly, updating the service. So I'm sure this will be gone at some point. So anyway, we should just enter one input. I don't know if you got the same issue, but there you go. So I'm gonna go back to opening a new chat lab, chat playground, sorry. Going back to Meta. And now I'm not sure which one I'm supposed to take. Sometimes we get a better output with Llama 2 chat 70b, 13b. So yeah, I'm still gonna take 70 billion. Apply, and there we go. Okay, so I'm gonna go back to the chat because I saw you wrote a lot of. All right. So yeah, we were at this side-by-side comparison. Let's have a look at your comparison. Cassie, did you get some similar thing? I don't know why the images are not uploading. Part 2 of the image above. Yeah, not sure what is going on with the upload. We'll have to leave in 5 minutes. Chuck Woody, okay, thank you so much for attending the first part of this lab. Of course, you will have the recording to see the next part. Thank you very much. Wesley, you said run into that error as well. After I tried to make it continue chat when it had a cutoff response, ended up restarting the chat playground. Okay, yeah, I get the same thing sometimes. Indeed, the best thing to do in those situations is to restart the chat playground. Similar, but not exactly the same. Okay, Cassie, okay, so you got some similar outputs when comparing 13B and 70B, but not exactly the same. So I guess we all have different things, and it's not deterministic. I think it's hard to identify some rules of, or some rules or differences between the outputs of 13B and 70B. Because it's not deterministic, sometimes we will get a better or more precise output with 13B, and sometimes with 70B. I think that's the conclusion to all this. But it was very interesting to, dig. It was an interesting topic to dig together. And Chin, thanks. Thank you, yeah, Chin. You're welcome. All right, so shall I move on with the next code generation use case, which will be for data science, or do you want to do another use case of code generation not related to data science? Let me know in the chat. Finally, your image uploaded. I don't understand what's happening because I have a good internet, so not sure. I can see it from here. Okay, but anyway, yeah. Cassie, you said that you had some similar outputs. Data science, let's go. Let's do this. Okay, perfect. So, yeah, you all agree to proceed with data science. Okay, perfect. Wesley, Janine, Cassie, you all want to do some code generation for data science now, so let's do this. So I'm going to go back to here. I think this is a check playground. Okay, perfect. And now let's start, let's do it step by step. We're going to start with a simple linear regression model, and that is generic. We're not going to provide a specific use case. We're going to provide a generic use case. We're just going to ask, well, let me show you. So what I want to say is, hi, please generate a Python code that builds a linear regression model which predicts, I'm going to say that predicts. Cassie, your English is your native language, I think. English is not my native language, so yeah, I think it's better to say that predicts. That predicts, no, that actually.
Right.
Huh?
Either way is fine, they're both correct.
Either way is fine. Okay, I never know, that sort of little things in English. That predicts dependent, because we're starting with a generic model, okay? A dependent variable y based on 3 independent variables, IV1, IV2, and IV3. All right, that's what I mean by generic. Then we'll use some more we'll do some more specific use cases, but since we're starting now, let's just build a generic model. Okay, so let's start. Let's read it again. Hi, please generate a Python code that builds a linear regression model that predicts a dependent variable y based on 3 independent variables, IV1, IV2, and IV3. Are you okay with that, or do you have any suggestion? Wesley, you say interchangeable. Okay, so you want me to say based on 3 interchangeable independent variables, IV1, IV2, and IV3? No, I think you mean that and which. Okay, sorry. Okay. It's you meant, never mind. Which versus that? Yes, okay, got it. Okay, so you all agree with this input, or I think it's fine, right? We just want to build generate a code to build a generic linear regression model. So let's see what it comes up with. Run. Here we go. The dataset has 100. Again, you see it upgrades my input. It imagines some stuff. The dataset has 100 observations and 4 variables. Yes, correct. 4 variables, 3. Okay, so it's pretty good. It just enhances the input to make which makes sense, right? Okay, please provide the Python code. Okay, so that's still the input. It did not do the code generation for the output. And that seems to be a recurring issue with Llama 2 Chat 70B. So if it doesn't work, what I'm going to do is I'm going to go back to 13B. So I'm going to say this, but it's not going to work because, we have this little bug. Okay, I'm gonna do this now. I'm gonna copy it, and I'm gonna click run in case it does the same thing. Yeah, there you go. So I'm gonna open the chat again, and I'm gonna go back to 13b. New chat playground, meta, 13b, apply. Okay, so I'm back with 13b. I'm just going to provide the simple input that I provided before. So I'm gonna cut this, but maybe we'll use it later. All right, so now let's see what 13b comes up with. Run. I would like to use the scikit-learn library, and the code should include the following steps. Okay, so again, it upgrades my input. Ah, there you go. Now we have the code generation. Very good. So yeah, chat 13b seems to be a bit better. Okay, and of course, we recognize that the code is entirely correct. Let's have a look at it. All right, so as you can see, it upgraded the input. That's the first part of the input, the part that I provided, and then the second part of the input that Llama 2, added to indeed make a more precise overall input. I would like to use the scikit-learn library, and the code should include the following steps: importing the necessary libraries, loading the data into a pandas data frame, perfect. Exploratory data analysis to understand the data distribution and correlation between variables, very good. For feature scaling, is that necessary for linear regression? No, it's not necessary. It's okay to use it, but it's not necessary. Split the data into training and testing sets. Okay, very good. Train the linear regression model. Very good. Evaluate the model performance with the mean square error. Very good. Or the R-squared value. Super. Make predictions on the testing set. Perfect. So I really like the plan of the code generation that it came up with. By itself, it's still the input, but it came up with that upgrade input by itself. Please provide the code for the above steps. Thank you. Hi there. Sure, I'd be happy to help you with that. Here's the Python code for building. Okay, so that's the output. The output starts here. Hi there. Sure, I'd be happy to help you with that. Here's the Python code for building a linear regression model using scikit-learn library to predict the dependent variable y, based on 3 independent variables, IV1, IV2, and IV3. And here we go with the code generation. So let's have a look. So first, an important necessary libraries. Very good. So we have linear regression class, perfect, from the linear model module. Then we have the train test split function from the model selection module. And then we have those evaluation metrics, mean squared error function and R2 score function from the metrics module by the scikit-learn library. Very good start. Then it loads the data into a pandas data frame. Perfect. That's exactly, so that's the name of your data set. Then it does the exploratory data analysis step. So this is a great function by pandas, which will give you some details of analysis on your data set. So that's really good. And then the correlations between the independent variables and the dependent variable. So that's really good. That's not something I usually do in my courses, my machine learning courses. So I'm glad that it came up with this. Then feature scaling. So it uses a standard scale class to build a scalar object, and then use the scalar object to scale the data set. But I remind that for linear regression, it's actually not useful or necessary to do standardization, because anyway, the coefficients can scale themselves to put everything on the same scale. Then it splits the data into training and testing sets. So yeah, perfect. Then it trains the linear regression model using the linear regression class. Perfect. So first it creates an instance of the linear regression class, and then it uses the fit method to train the model on the training sets composed of X-train and Y-train. And then it evaluates the model performance by using the predict method from the model. It calls the predict method from the model because it's an instance of the linear regression class. And then it finally uses the MSC, the mean squared error function and the R2 score function to compute respectively the mean squared error loss and the R2 score, the R squared. Perfect. So the code generation is entirely correct. It did the job perfectly. And not only that, but also it provided an upgraded version of the input. So what do you think? Pretty good, no? Thank you, Wesley. You are a Python expert at the beginning. Yeah, the little compliment can maybe improve things. Okay, so yeah, pretty good code generation, right? We make a good start in terms of code generation for data science. Mine is not polite like yours. Okay. Yeah, anyway, we all get different outputs anyway. We all get different outputs. All right, so I think you all got some correct outputs, right? You all got the correct code. I guess most of you are data scientists here, so you recognize that indeed the code is completely correct, and it did exactly what we wanted. Of course, using scikit-learn. Okay, good. So let's move on with the next data science use case. Now we're going to do the same, but with classification, and we're not going to ask for a generic model. By the way, if you want, I can copy this for you and provide it in the chat. So now we're going to do the same, but with classification, and not with a generic example, but with a specific example. We're going to do something fun. So, of course, I'm going to open a new chat playground, select model. So I was wrong. The best model seems to be the chat 13b. So I'm going to take the chat 13b now, apply, and here we go. So now we're going to build a logistic regression model because we want to do classification, and we're not going to build not going to do a generic use case. We're going to do a specific use case. How about we build a logistic regression model that will predict the next president of the United States. Okay, that's what I mean by specific versus generic. So I'm going to say, hi, please generate a Python code that builds a logistic regression model that predicts the next president of the US based on many input variables. Hi, please generate Python code that builds a logistic regression model that predicts the next president of the US based on many input variables. So you understand that logistic regression is a good fit, right? Because it's a classification problem. There are only a few candidates, therefore several categories to predict. So yeah, let's do this. What do you think? Did I get any comments? No. Okay, so I guess you're all okay to try this. So yeah, I'm not too specific. I don't know which input variables we could come up with. Well, actually, I did the example before, and the output I got was really amazing because it provided several examples of input variables. But there we go. We click run. Let's see what happens. Then, oh yeah, it did the same. Perfect. The input variables are, so now it's the part where it upgrades the inputs, and it's even better than when I tested it myself. Maybe that's because I did it with 17b. Ah no, now we have the same problem as before. It did not do the code generation. Okay. So the input variables are the current president's approval rating, the number of years since the last presidential election, okay. So we have all these input variables, and then it says the output variable is the predicted probability of the next president being a Democrat or Republican. Please use a Python library such as scikit-learn to build a model. So that's still the upgraded version of the input. Here's the data. Okay. Please note that this is a fictional data set, not based on it. So unfortunately here, it did not do the code generation. So what I'm going to simply do is open a new chat playground and try again. Seems to be, I can always try 70b. What do you think? Should I go back to 13 or do 70? Okay, so I'm going to try again. Run, and let's see what we get this time. Here's the data. Okay, so it comes up with several independent variables. Okay, so that's still the part where it upgrades the input. Here's the desired output. Explanation, thank you. Okay, so thanks, but please generate the code. Ah, it's still the same problem. That bug by Bedrock. Okay, so sorry about that. We're gonna open a new chat playground. I'm gonna try 70b now and run. The same, it upgrades my input first with many different IDs of independent variables. Ah, there we go. Now we have the code generation. So, sometimes Llama 2 chat 13b is better. Sometimes Llama 2 chat 70b is better. It's hard to know exactly, the rules or exactly what is going on, but there we go. I guess the other conclusion is that we have to try several times. Oh, unfortunately, it did not finish the code generation, but let's see what it came up with. All right. So first, of course, it upgraded my input by giving the different independent variables that we could have to predict the next president of the United States. And here, the independent variables seems to make sense. I'm not from the US, so you will tell me better. But that's the independent variables it came up with. Then I want to build a logistic regression model that predicts the next president of the US based on these input variables. And here is the code generation. Please provide a Python code that accomplishes this task. So import pandas as PD from a scalar and import train test split. Then from the linear model module, import logistic regression class, perfect. And then import the accuracy score, classification report, confusion matrix. All right, so first it loads the dataset with the read_CSV function by pandas, perfect, president data.csv. Then it pre-processes the data. Okay, so here it removes the target variable to only get the matrix of features X. And besides, it dropped some columns: votes, popular votes, electoral votes. Okay, you will tell me better if this makes sense. And then it gets the dependent variable Y, of course, the target variable, which is the votes. Okay. Then it splits the data into training and testing sets. Okay, using the train test split function. Train a logistic regression model, logistic regression class. Then it uses the fit method to train the model on the training set composed of X train and Y train. And then it uses the predict function on X test. Yes, but what is X test? Okay, that doesn't make that much sense. Because I asked for the next president of the US in 2024, right? It's next year. So yeah, it gave a pretty good code generation, but not exactly what I wanted. Please tell me your comments. 13B worked for you. Okay, Cassie, would you like to share your output? Either with an image or by... Okay, good. All right. Yeah, it stopped at the actual logistic regression. Okay. Okay, you got the beginning, but then it stopped. Okay. Does anyone else have an output to provide? Okay, just following along visually. Okay. So yes, we have some good but incomplete code generation, both from my side and from Cassie's side. But at least, yes, it gives us an idea on how to build a logistic regression model. I guess if we do several tries, we can always improve this. I can try to do it one last time. We can also try in the text, by the way. Text, meta, llama 2, apply. But we will only have one chance. Run. Okay, so here it again upgrades my input. Okay. Okay. So there is a... Yeah, so it did not do the code generation here. Yeah, no. I guess the chat is better. So I'm going to go back to the chat. I'm going to try one last time with 13B. You know what? I prepared actually this. This is the input. This is the input that I entered last time. Or also this part of the input with all the variables were the part upgraded by Llama 2. So let's try this. Yes, and I did XGBoost. That's for the more advanced part. I'm still going to say logistic regression. Run. Please provide a detailed explanation of each variable and how it was encoded. Okay. Here is the input if you want to have it. Okay, both got stuck in 13B and 70B. Interesting. Okay. Okay, so here, please generate the code. Okay, so that's still the part where it upgrades my inputs. Oh no, it stops. Okay, that's a shame. Please generate the code. I don't know what to say. There we go, finally. So you see we have to insist a bit. So now it generates the code. And now we seem to have the old code. Yes, perfect. Yes, now we have it. Okay, so yes, that's the advantage of using the chat playground, is that we can provide several inputs and insist a bit. So that's exactly what happened here. I insisted a bit, and it finally did the code generation. All right, so first we load the data with the read_CSV function. Okay, good. Then we pre-process the data. Okay, oh, so that's an optional step. Then we split the data using the train test split function. Then we build the model by creating an instance of the logistic regression class perfect by the LR library. Then we use the fit method to train the model on the training set composed of X train and Y train. Then we evaluate the model and we make predictions. Okay, so we use the predict method. We call the predict method from the model on X test. And okay, we have the final prediction. But it still doesn't provide the exact code to predict the next US president. But that's okay. I mean, at least we get the whole code on how to build a logistic regression model for a specific case study. But as you can see, it's easier to build a generic model than a specific use case, than for a specific use case. All right, let's see your comment. Okay, so yeah. So yes, Cassie, thank you for letting us know that in compare mode, you both got stuck. But indeed, if we insist a bit, we get the end. All right, so there you go. That's the example I wanted to show you. Now we can finish with a final example with a more advanced model, either with a generic use case or a specific use case. And that can be, you know, a gradient boosting model, an XGBoost model, or even a deep learning model. So let's see. I'm going to open a new chat. Select model, meta. I'm going to take 13, apply. All right, and I'm going to say this time we're going to make it generic. You know, it seems to be easier for Llama 2 to provide the output. So I'm going to say, hi, please generate a Python code that builds. So we're going to test a more advanced model. Let's do for classification. So that builds an XGBoost model to predict a dependent variable y based on many independent variables. All right. Hi, please generate a Python code that builds an XGBoost model to predict a dependent variable y based on many independent variables. I just want to see if it can build a more advanced models by using some other classes. So let's click run. All right, I want to use the XGBoost library in Python. Here's the data I'm working with. Okay, so great. It really made it more generic. So going from feature 1 to feature n. Oh, wow, it even creates some kind of notebook here. That's pretty cool. Very good. We get a very good output here. Ah, incomplete. Okay, but at least I think we got the whole code generation. All right, so I really like how it upgraded my input because it says, okay, I want to use the XGBoost library in Python. Here's the data I'm working with. I really like this part, you know. It says the ID, feature 1, feature 2, feature 2, feature n. So it gives, it defines really what are the generic independent variables, and then at the end, the dependent variable y that we want to predict. And then it says I want to use the XGBoost library to build a model that predicts the dependent variable y based on the independent variables feature 1, feature 2, feature 3, feature n. Here's the Python code I've tried so far. Import XGBoost as XGB, so that's the XGBoost library. It gives the XGB shortcut. Then it loads the data.csv. Then it split the data into training and testing sets using the train test split function, okay? And then it created the XGBoost model. So for classification, yes, XGB classifier, which is the exact class. I know because I implemented the XGBoost model for classification many times. So that's exactly correct. Then it trained the model on the training data with the fit method called from the model object by the XGB classifier class. Then it makes predictions by calling the predict method from the model on XTest. Then it evaluates the model using accuracy score by calling the accuracy function called from the model and on XTest and YTest. So perfect. The code generation is entirely correct. And that's exactly how you would build an XGBoost model for classification. So that's exactly correct. Unfortunately, it did not finish the text generation, but that's okay. We got the whole code generation. All right, so the conclusion of all this is that so far with Llama 2 chat, whether it is 13B or 17B, sometimes we will get better outputs with 13B and sometimes better outputs with 17B. The conclusion of all this is that Llama 2 chat can do some good code generation when we're not too specific in our inputs. You know, when we ask it to build a generic model, well, not only it will provide the correct code generation, but also it will upgrade your input in the right way. However, when we try to generate a code for a too specific use case, we will have a bit more trouble. And the other conclusion is that so far we got a pretty satisfying output for code generation with Llama 2 chat. But remember that code Llama 2 will be released soon, at least within Bedrock. So definitely when code Llama 2 is released, we will have another lab doing some more code generation, and we will see how it improves the code generation we witnessed today. All right, so, okay, is that, yeah, William. Hey, William, I didn't see you before. How are you doing? Good that you're here. So, William, you gave your example of prompts, and you said, good afternoon, working to get the correlation matrix. Okay, so that's your output. So first it upgraded your input. Okay, so you did another example for customer churn. Okay, interesting. Okay, so here, if you're interested, William did the same for a customer churn use case, therefore specific. Therefore, I don't know, William, are you satisfied with the output? It's a bit hard to say here. Oh, you even got, but that's in R, no? I think that's in R.
Good afternoon, everyone, and sorry for
hey, William. No.
up here.
Glad that you're here.
Yeah, so I provided the code into the prompt, and I also was a little specific on what I wanted to achieve and get done. And I was actually really, really happy with the R code to
nice.
that they returned and revised for me. It actually optimized my implementation.
Oh, great. Awesome. Yeah, it's really interesting that you gave us this as example, because I only did it in Python. But yeah, it's good to know that it also works very well as well for R, and you even did it on a specific use case. So glad to know that you're happy and satisfied with the output. Thank you, William, for sharing this. Thank you very much. So yeah, that brings us to the end of this lab. I wanted to show you, some first general example of code generation with this function that checks if a number is a prime number. Yeah, AWS is going to take all my money. This is too fun. Yeah, me too. I'm so scared, and I have to monitor this on a regular basis. So yeah, that brings us to the end of this lab. We did the first general code generation example, and then we did that for data science. We're always satisfied with the output when the input was not too specific. The use case was not too specific, and it did very good when yes, the use case was generic. However, when we were too specific in our output, working on a too specific use case, we got into a little bit of trouble, but by insisting, we finally got the code generation. Thank you, Cassie. Thank you for saying it's a great lab. We will have many others. I remind that so far we're only doing once a month, because also Kira and I are super busy making a course, by the way, which I'm uploading at the moment, so it will be released very soon. I will click the publish button probably by Saturday or Sunday, so you will have it this week, at least the first batch of content. But there you go. What I was saying is that so far we only have one live lab per month, but at some point we will bring more experts and more instructors into this platform, which will give other labs, which you will decide to join or not, but at least you will get some other labs on other topics. So yes, a lot more is to come. So thank you so much for attending today. If you have any questions, some final questions, feel free to shoot now. I'm glad to answer. But again, I was super happy to give you this new lab, and I look forward to doing the next lab. I don't know on which it will be yet, but maybe if we get Code Llama within Bedrock by the next month, well, maybe I'll do it on Code Llama. Okay. Thank you, Marco. Thank you for attending and for your feedback. And yes, I look forward to seeing you in the next live lab. Thank you very much. Bye-bye.